For this video, we're going to continue with examples of hypothesis testing for means and proportions. In this video, we're going to perform examples of cases where we are testing a claim about a mean and our population standard deviation is not known. Our first example says a researcher found that a cigarette smoker smokes on average 31 cigarettes a day. She feels that this average is too high. She selected a random sample of 10 smokers and found that the mean number of cigarettes they smoked per day was 28. The sample standard deviation was 2.7. At alpha equals 0.05, is there enough evidence to support her claim? So again, in that last part of the problem, I see the question is asking about evidence to support a claim, and I know that that's telling me to perform a hypothesis test or a significance test. I can also see that I'm given a significance level, alpha is 0.05, and then picking through the rest of the wording, I can see a sample standard deviation of 2.7. I see the sample mean was 28 cigarettes per day. And back at the beginning, I can see that the average was 31 cigarettes per day. So we're going to go ahead and follow our step list from earlier in this unit. So I know my first step is to define the variable, and I know that I'm testing a claim about a mean, and it's the average number of cigarettes a smoker smokes per day. And then I'm going to pick off the values given in the problem. So I'm given a claimed value for that mean of 31 cigarettes per day. I'm given a sample mean of 28 cigarettes per day and a sample standard deviation of 2.7 cigarettes per day. I'm then told to test my claim at alpha equals 0.05. My next step is to state the hypotheses and identify my claim. So I know that I need a null and an alternative. And I'm searching through that problem for some keywords or key phrases about the claim. How do we feel about that 31 cigarettes per day? And the answer is that the researcher feels that this average is too high. She thinks that 31 is too large. My null is the claim that the mean cigarettes per day for a smoker is 31. The researcher feels that's too big, meaning she feels the mean is actually less than 31. Since I'm testing a claim about less than, I know this is going to be left tail. I need to identify the distribution I'm going to use to perform this test. And since I have the sample standard deviation and it's a claim about a mean, I know that means that this is a t-test for the mean. Next, I'm going to calculate my test statistic and my p-value. Words are hard today. So I'm going to draw my student t-distribution. And then I'm going to use on our calculator t-test, stats test, t-test is for a student, t-test for a single mean. And I know that that calculator command, t-test, asks me for the claimed mean, the sample mean, the sample standard deviation, the sample size, and then a statement about the alternative. So for us, the claimed mean was 31 cigarettes per day. The sample value was 28 with a standard deviation of 2.7. And back in our word problem, we forgot to underline that she took a sample of 10 smokers. So we know that our sample size is 10. And then we're testing a claim that is a less than statement. So let's go ahead and enter that in our calculator. Whoops. Didn't even notice that was happening until I looked up. Let's try that again. There we go. And I'm going to go straight to draw this time. And I get my test statistic. So I know my t-test statistic is negative 3.514 rounded. And I have a p-value of 0.0033. And I can see from my calculator that that negative 3.5, that's way out here in that direction. Which makes sense because I can see that my p-value, the area or probability in that tail, is very small. I then need to make my decision and summarize my result. For my decision, my p-value of 0.003 is less than my alpha. And when that's the case, my sample size is extreme enough that I am going to reject the null, which means that I have evidence to support the alternative. And remember that we would write 2 sentences in summary. Because our p-value of 0.0033 is less than alpha equals 0.05, we reject the null hypothesis. And then our second sentence would say, there is sufficient evidence to support the claim that the number of cigarettes that a smoker smokes on average is less than 31 cigarettes per day. All right, let's go ahead and try another one. So this second example says a researcher estimates that the average height of the buildings of 30 or more stories in a large city is at least 700 feet. A random sample of 10 buildings is selected and the heights in feet are shown. At alpha equals 0.025, is there enough evidence to reject the claim? So we'll go ahead and start picking through that problem. I see, is there enough evidence to reject the claim? I know that's telling me to do a hypothesis test, and I can see that there's a level of significance attached to that. I see that a claimed statement about the height of buildings of 30 stories or more is 700 feet. And you'll notice at least 700 feet, that means 700 feet or greater. But remember that our null is always a statement of equality. We don't have to worry about the or greater part. They tell me that we have a random sample of 10 buildings. So I know n is 10. They didn't give me any other information. So I'm going to go ahead and start this process with what I do have. I know my random variable is the average height of buildings of 30 or more stories. I know that the claimed value for that mean is 700 feet. I know that my sample size is 10, and I know that my level of significance is 0.025. I'm going to go ahead and state my hypotheses. I have a null, I have an alternative. I know that my null, I have mu equals 700 feet. I know that my alternative is going to use that same parameter and that same value. I now have to figure out the inequality. My original statement is at least. That means 700 or more. The complement to that, what I should use as my alternative, would be less than. So if I want to reject the claim that they are at least 700 feet, I need to show that they are less than 700 feet. Since I wasn't given a population standard deviation and was instead just given sample data, I know that I am doing a t-test for a mean. And once I've identified my test, I'm going to go ahead and draw my distribution and then use my calculator to find the test statistic and the p-value. In this case, because I was given raw data, I need to put that data in a list on my calculator. So stat, enter, and we're going to type those 10 numbers into list 1. I'm fairly certain I typed those correctly. I know I have the right number because my last value is in cell 10. And then I'm going to run my t-test command on the calculator to get my test statistic and my p-value. So let's go ahead and pull that command up. And when I highlight data instead of stats, it asks me a different set of questions. So it asks me for the claimed mean. It asks me where I put my data. It asks me if I had a frequency list, meaning was my data grouped. And then it asks me for my alternative hypothesis statement. So we know that our claimed value is 700 feet. We put our data in list 1. We didn't have a frequency list, so each value occurs once. And this is another less than statement. And the calculator tells us that our test statistic is negative 2.711, rounded. We usually round t values to 3 places. And that I have a p-value of 0.12. Or 0.012, rather. And I can see very clearly it's marked on my calculator. Oops, I meant to do that in color. And I can see that area. And that's why my p-value is a little bit larger than it has been in some of our previous examples. based on my p-value of 0.012, 0.01 is less than 0.02. So my p-value is less than my alpha, which means I reject the null. So that means that I have enough evidence to reject the claim that the height of buildings is at least 700 feet and support the claim that the height of buildings is actually less than 700 feet. All right, so that's how a t-test for a single mean is conducted. If you have any questions, feel free to send me an email or drop by office hours. Otherwise, I'll see you in our next video.